Hello friends, today we are going to solve another engineering dynamics problem of chapter 15, kinetics of particle, impulse and momentum. So our target chapter section for today is chapter 15.3, which is conservation of linear momentum for a system of particles. You should have watched the video of the theory part session from another video that we have already posted. Here we're going to solve problem for the session or section 15.3, conservation of linear momentum. So what is our goal for today? So we're going to solve problem from chapter 15.3, and I think it is also worthy to compare this problem with the previous problem that we solved for 15.1 to 15.2, which is principle of impulse and momentum, how it is different. And then our last goal for today will be discussing, we'll discuss throughout the solving problem at the beginning of the problem mostly, where and how can we can start solution. So our discussion will lead us how do we select, how to proceed with the solution. So let's read the problem and start our solution. So the problem says a 2.5 megagram pickup truck is towing a 1.5 megagram car using a cable. We can see in the image the truck is this one, and the car is towing this car using a cable. If the car is initially at rest, so this car is initially at rest, and the truck is coasting, this truck is coasting with a velocity of 8.33 meter per second, which is actually 30 kilometer per hour, when the cable is slack. So initially, when this truck started to move at 30 kilometer per hour, this cable was slack, and this car was at rest. So we have to determine the common velocity. So what is the velocity of the common velocity of the entire system, truck and car together, of the vehicles? So common velocity just after the cable become taut. So when the cable become taut, what is the common velocity of both of them? And also determine the energy loss. So the given are the mass of the truck, mass of the car starts from rest, so initial velocity is 0. The initial velocity of the truck is 8.33 meter per second. We have to find what is the combined velocity of the both car and truck, both vehicles, and also we have to find the energy loss. So how do we proceed to solve this problem? Can we solve this problem using the concept we have learned in chapter 12, 13 and 14? What are the things that are different in this problem compared to the other chapter problem, or compared to the very last example we did, that is 15.10 that we just solved on this chapter, how they're different, so we can apply the conservation of linear momentum in this problem. So now let us take a few moments here to compare our current problem with our previous problem that we just solved from chapter 15. So in this problem we also have given the mass, also previous problem had a mass given, and we were also looking for the force here. And in current problem we have the basic difference are we have multiple particles. So we have one truck and we have a car. Previous problem we had only one crate. Another thing, at the beginning we had individual velocity, different velocity. The car had a different velocity, which was 8.33. The truck had 8.33 and the car was 0. And then we're looking for a combined velocity at the end. Here we had only a crate, and it was starting from 0, and the final velocity is given, so we can find the acceleration. Here, this truck and car also have acceleration, but we're not looking at individual acceleration. And at the end, we started with separate velocity. We're looking for final velocity as a combined system for this problem. So we at the end we consider it as a single body. And also one thing to notice is that in this problem there is no time length given. And we know that for impulse we need time. So in this problem, the previous problem, we had time given for 5 seconds, so we can use that time for impulse, and then that is the different thing from this problem. And also we'll see when we start solving our current problem today, we'll see that how there is no impulsive force acting. And that's why we also don't need to look for time, because sometimes the time is not given, and you have to find, using the information given, how much time is passed. Since there is no distance given, so it is hard to find the time out of this problem. And also, if there is no impulsive force in this problem, why we would need to look for time and look for impulse. So this is the difference between this problem and that problem. Now I think let's move on and start solving our current problem. So how do we start solving this problem? From this problem we see the mass is given, the velocity, initial velocity is given, and then the final combined velocity is asked for. So mass, velocity is kind of momentum. And also you can look, it's a system of particles. There's two body involved. In our previous chapters we did not saw there's two vehicle moving at the same time, or this kind of scenario was not seen. So it was a system of particles. So now the question comes, okay, maybe I'm gonna use chapter 15 concept to solve this dynamic problem. But again, should we use the principle of impulse and momentum, or should we use conservation of linear momentum? So now that question can be answered if we ask ourselves, is there any impulsive force acting? And how do I find that? We have to draw free body diagram. So if we draw the free body diagram, we see for the truck there is a weight downward, and then there is a normal force upward, equal and opposite. There is no force acting any other direction. So the velocity is in this direction, and they are the normal forces are perpendicular, so they are not acting along the direction of the movement. Also, the car has a weight downward and normal force upward, counter and opposite, canceling each other. And they had initial velocity, but here, if you see the force, they are counter and opposite, because the truck is pulling the car, so there's a tension, and then the car is kind of pulled forward, so this is in this direction, so they are counter and opposite, so that also cancel each other. So in a nutshell, there is no, if you take the sum of all external forces, these are all our external forces, if you consider the entire body, there is no external forces active, so external impulse would be 0, and since there is also, we're not considering the time length, so there is no impulsive force, so we can use the conservation of linear momentum here. So once we figure out that we can use the conservation of linear momentum, now that is sweet, because from now on we can just plug the values and see if there is more unknowns needs to be solved, or we can just solve as is. So we just write down the equation for conservation of linear momentum, I could have write this term as described in textbook, mtv, the final velocity, and mcv, the final velocity of the car, multiplied by the mass of the car. Since these both v are the same, it's combined, so I take it as a common outside, so I wrote this term. Now all we have to do is check whether we know all the values. We know the mass of the truck and the car, which we know. This is the unknown we're looking for. We can say also v2 or v. This here, we know the initial velocity of the truck, mass we know, and initial velocity was 0 for the car, so that's 0. So there is no more unknown. There's only one unknown. And we can find the final combined velocity of both truck and the car, which is 5.028 or 5.2 if you write. We called it v, so let's keep it as a v. So the v is the combined velocity of our problem. So that's the one answer that we need. Now we also have to find what is the energy loss. So how do we find the energy loss? What we would what are the approach we can take to solve and find the energy loss? So just remember or try to recall what are the energy term that we have discussed so far. Right. We had so far discussed kinetic energy, and we also have discussed potential energy. For this problem, which energy we should use? Kinetic or potential? Or both? I don't know, right? So let's check in our problem. Does this both truck is moving? Yes. So we should have some kinetic energy. Well, now the question is, should we also have potential energy? Yes or no? No, because see, if we check our potential energy equation, mgh, we have mg 9.81, but h, height. The car is not moving upward. It's not changing its y direction position. So there is no, h would be always 0, and so there is no potential energy. So we can cancel out the potential energy, and we figured out that we have to only deal with the kinetic energy part for this problem. So the next question, how do I find the energy loss? How do you find loss? Well, simple. If you think of a business, how do you find your loss or profit? If you started with $100 at the beginning of your business, and after the business you had $80 left, how do you find loss? Before minus after. Or if you have profit, if you started with $100 and you end up having $120, so meaning it will be negative. So that means positive, meaning it's opposite of loss, so that's a profit, right? So how do you find loss? Just take the difference between before kinetic energy and after kinetic energy, and it will see if it's a loss or like a gain. I mean, it will always have a loss because we're not generating any energy. So we'll find the energy right now. So let's find energy loss. The equation could be the change or the initial kinetic energy minus the final kinetic energy of the system. We put C because we're talking about the entire system, not a single car. So we're going to consider the both as one combined system, one particle. So we are assuming it's a combined. So the initial kinetic energy, T1, of the combined set is half mv square of the initial truck plus the car. Car was at rest, so that we don't have to worry about it. The v is 0, so that's 0. So we only have mt, which is we know here, and VT is also given. So we can find, if you plug the value, your result should be around or approximately close to 86,805 joule. So what is the final kinetic energy? Well, we know the final combined velocity, so we have to use combined mass, and the equation is half mv squared. So again, if you plug that, you'll get an approximate value of 54,253. So how do we find the loss? You have to just plug this T1 here and T2 here, and you will find the loss, which is 32.6 kilojoule. Around, you should get around value 32.6 kilojoule. So that is our second answer. So now all you have to do is that plug this numerical value and check your answer and practice a similar problem from your textbook. If you need more clarification or you have more questions, you can always comment below, and I'll try to explain with more explanation or more image if I have to. So in our next session, we will solve problem from chapter 15.4. But till then, see you in next video. Thank you.